All right, so what we have to talk about are what are known as our log properties. We've already talked about exponential properties, right? You're going to find they're very, very similar. Okay? Why? Well, what is a logarithm? They're just rearranged exponential equations, aren't they? Like when we see a log expression and we have to solve it, what's the first thing we do? We just take it and rearrange it into exponential notation, don't we? So a logarithm really is nothing but a rearranged exponential equation. So it actually makes a whole lot of sense that all of our exponential properties actually then hold true with logarithms, right? Because they really are just exponential properties. Now, these exponential or these log properties, that's basically all they are. Is if we take our exponential properties and we rearrange them, we end up with these. Okay? So, your first log property. If you ever see a log, and it doesn't matter what the base is, we're just going to put a b down there. It could be a 2, could be whatever number you want. Log base anything of. And then on the inside of the of, you have two different things multiplied together. X times y. Well, what you can do with that is you can rewrite that and give each part its own logarithm. So you can say that's the same thing as log base b of x and log base b of y. Give each part its own logarithm. And what do you think they're separated by? Think about rule number 1 with exponents. If you have two things multiplied together with the same base, what do you end up doing with those exponents? You add them together. This really is just rule number 1 in exponential properties rearranged. What do you think rule number 2 is going to be then? If you have log base b of, and now you divide. X divided by y. Well, again, you can give the x and the y its own logarithm. But what do you think you do? When you divide, we end up subtracting the exponents, don't we? So it ends up being the same kind of thing. Make sense? These two rules are pretty easy to see where they come from. If you just think exponential properties, rule number 1, rule number 2, it's not hard to see why they are what they are. Rule number 3 is a little bit harder to see why it works, but as soon as you start simplifying exponent or logarithms, it does make a whole lot of sense of where it comes from. So we'll get to that one. But the rule is this. If you have a logarithm, and then inside the of, you have a number, and that number is raised to an exponent power. So we have log base b of x to the y. If you ever see an exponent in an of part, what you can do is you can take that exponent away and basically just move it right out front and multiply the whole logarithm by that. So you end up with log base b of x to the y is the same thing as log base b of x times y. Okay? So those end up being the same thing. Okay? They're the same rules that are in your book on page 348, actually. The book uses m's and n's instead of x's and y's. I hate those letters in rules because you start saying m and n and m and n and it just sounds weird and it's really hard to understand and I don't like using them. So x's and y's are just better. Fair enough? So here's basically what we can do with those. if you see a crazy logarithm, like log base 2 of 4x to the third power y to the fourth, all divided by z squared, that whole thing is in the of. Yuck. Well, what you can do is you can expand it. You can take that one ugly logarithm and write it as a bunch of individual logarithms. We can give the 4 its own logarithm. So we can say that's the same thing as log base 2 of 4. This is 4 times x squared, right? Or x to the third. So times, we would separate with a plus log base 2 of x to the third, but we also have a property that, what do we do with our exponents? Put it out front. So instead of writing that as a third power, we just put that 3 right out in front. This is also times y to the fourth. So plus 4 log base 2 of y. All right, and then it actually switches to division now, right? So what do we do with the z squared? Well, minus 2 log base 2 of z. So now that we've taken this big logarithm and we've expanded it into a bunch of little ones, well, now they become easier to handle. I can simplify each one of them individually as I go if I need to throughout a problem. For example, I know what log base 2 of 4 is. Because all this is saying is 2 to what power is equal to 4. This whole thing is just 2. So I could, if I wanted to, simplify them now individually. The rest of these we can't because they're letters. But you get the idea of how I can then simply simplify them individually now. Because sometimes things are easier to deal with as individual parts. In the next homework assignment, you're going to get 2 types of problems. You're going to get one little logarithm, and you're going to say expand it. And you got to expand it into a bunch of little ones. But then you're also going to get something that looks like this, and it's going to say condense it. And you got to go back from this long thing back into one single logarithm. The properties work both ways. And the reason we want to be able to do this is sometimes we're going to end up getting to where we got to solve these ugly log equations. Sometimes it's easier to deal with them individually. So if we see them together, we want to break them apart. Sometimes we see them written apart, and it's just a whole lot easier if I can put them together as one and then deal with it. So we want to be able to go in both directions. Okay? Everybody take a look at...
Please excuse me for this announcement. If you are a student in Mrs. Scalva's first period class, again, Mrs. Scalva's first period class, please report to room B506, which is across from the art room, during triple A. Again, Mrs. Scalva's first period class, please report to B506 during triple A.
Someone's in trouble. Someone stole something. Oh, it's just SAT stuff, probably. Okay, huh? They're definitely in trouble. All right, page 351. Page 351. So if you are looking at classroom exercises, practice exercises. Number 1 just says, take log base 3 of xy and expand it. What would that just be? Log base 3 of x plus log base 3 of y. Done. That's all there is to it. when you get to a problem like number 7 that says log base 3 of x over 5, you'd write log base 3 of x minus log base 3 of 5. Easy enough, right? How would you do a question like number 11 that says log base 6 of the 5th root of x? Yes. Remember, the 5th root is nothing more than an exponent. That is the same thing. The 5th root of x is the same thing as x to the 1/5. What do we do with exponents? You just bring that 1/5 out in front, and it would just be 1/5 log base 6 of x. So if you see radicals, don't freak out. They're just exponents. They're just fractional exponents. Yes? Easy? Now, a problem like number 16 trips up a lot of people. It says log base 3 of 4x to the 4th power. The key to this is to remember what here is actually raised to the 4th power. Both of them, isn't it? We'll do some practice problems tomorrow in class. Have a good day.